Assumptions and logical strength. Mathematical arguments in economics are only as strong as the premises they are built upon. In other words, the conclusions we draw from mathematical models depend entirely on the accuracy of the assumptions or premises used in the model. For example, consider the premise: if wages rise, employment falls. This premise suggests a direct relationship between wages and employment. If this premise is incorrect or unrealistic, then no matter how sound the algebra or mathematical structure is, the conclusion drawn from it will be invalid. This highlights an important point. Strong mathematical logic can only lead to valid conclusions if the premises are accurate. If the assumptions underlying the model do not hold true in reality, the results derived from the model will be flawed, regardless of the mathematical rigor involved. Therefore, it's crucial to critically examine the premises before trusting the conclusions of any economic model. Mathematics narrows investigation. Mathematics in economics can be incredibly powerful, but it often narrows the investigation to focus on specific areas while potentially ignoring broader contexts. Think of mathematics as a spotlight. It shines a bright light on certain aspects, providing clarity and precision. But in doing so, it can blind us to the bigger picture. For example, in a natural language debate about wages and employment, we might discuss not only economic factors, but also cultural, social, and political influences. Issues like workplace norms, government policies, and societal values that impact labor markets. However, a purely mathematical model might focus only on quantifiable aspects, such as the relationship between wages and employment, and may overlook the deeper, more qualitative factors. While mathematical models offer clear, measurable insights, they can miss important complexities that shape real-world economic dynamics. Therefore, it's important to remember that while math provides clarity, it can also narrow our perspective. And sometimes, we need to step back to understand the broader context. Quantities in economics. In economics, we often deal with variables like labor and capital, but it's important to recognize that these terms aren't as simple as they might seem. Both labor and capital are not homogeneous. They're made up of a variety of components that vary significantly. Take labor, for example. Labor doesn't just refer to a generic workforce. It includes workers with diverse skills, backgrounds, and expertise. A carpenter, a software developer, and a nurse all fall under the broad category of labor, but each brings a unique set of abilities to the table. Similarly, capital isn't just a single concept. It includes tools, machines, and buildings, each with different characteristics and functions. A factory machine and a computer, though both considered capital, serve entirely different purposes in the production process. For instance, the Cobb-Douglas production function uses K for capital and L for labor to model production. While it's a useful tool, it doesn't capture the qualitative differences within these categories, such as the varied skills of labor or the distinct types of capital. It treats labor and capital as if they were uniform, ignoring the nuances that can significantly impact economic outcomes. Mathematics, of course, is an invaluable tool in economics, offering clarity and precision. However, it's important to acknowledge its limitations. Mathematical models depend on assumptions, like treating labor and capital as homogeneous, assumptions that may not always reflect the complexities of the real world. While these models provide detailed insights, they can overlook important qualitative aspects of economic systems, such as the human and social factors that influence labor and capital. The key takeaway here is that mathematics should be used judiciously. It's a powerful tool for understanding economic relationships, but it must be balanced with an appreciation of the real-world complexities that often cannot be captured by numbers alone. Assumptions